Hi everyone. So today I am going to start the topic probability. So you have been introduced with this term probability in ninth class statistics chapter. So let us do some recapitulation of what you've learned in ninth class. Okay. So what was the definition of probability? The probability gives the numerical measure of the chance of occurring an event of a random experiment. So let me write down the definition first. So probability is the numerical measure of the occurrence or of the chance of occurrence, better let me write, numerical measure of the chance or likelihood, which means likelihood is the numerical measure of the chance or likelihood of the occurrence of an event. Of an event in a random experiment. Now, what is random experiment? And random experiment is an experiment where the outcome of that experiment is unpredictable. For example, toss of a coin is a random experiment. That is, if you toss a coin, you cannot predict what will be the outcome, whether it will be head or tail. So it is a random experiment, and the event will be whether it is a head or tail. Similarly, another example of random experiment you can take throwing a die. Okay, so when you throw a die, you don't know which face will turn up. It may be 1, it may be 2, 3, 4, etc. So that is also a random experiment. And then also your picking a card from a well shuffled 52 well shuffled pack of deck of playing cards. That also you don't know which out of 52 which card will pick up. Okay, so these are all random experiments. So when I define an event, that is, I want when I when I toss a coin and I want it should be head. Suppose in cricket match, when which team will be batting is decided upon the tossing a coin. So if it decided that the event should be head, if head appears, then this team will bat in this way. So and obviously the chance of occurring that head is important, and that is also uncertain. So these are all random experiment. And so when I define the event by say event of a random experiment we define by E, then the probability of that event is denoted in this way. This is the probability. This indicates the probability that event E will happen. Okay. And you see, sometimes when an event is sure to happen, suppose when I throw a die, and if I define my event like this, say that the number that will come up will be less than or equal to 6 and more than or equal to 1, then that is sure to happen. In that case, that is known as sure event, and so naturally the probability will be 1. So the probability is the numerical value. So the numerical value that I have given numerical measure. So the maximum value of this probability is 1. So it may be less than or equal to 1. Okay, again, there are also impossible event, that is, which is not possible to happen. Suppose when again in the throw of die, if I define the event to be a number which is greater than 6, it will never happen. There is no such number on the die which is more than 6. So in that case, the probability is 0. That is the minimum value of the probability. So we can say the numerical value of the probability of an event must lie in this: 0 for impossible, 1 for sure event. So generally when there is uncertainty associated with the outcome of the event, then it will be a fraction. It will be lie between 0 and 1. So okay, this is about the numerical measure of the probability. Okay, now in 9th class, what we have done, how we have defined the probability? We have defined the probability in this way, that is probability of an event. What you have done, you have performed the random experiment a number of times, and each experiment was known as a trial. So what you've done experiments, and when you are performing the trials, you have noted down how many times our event has occurred. You have to note down that number. So, and then the definition is given in this way: total number of trials upon number of trials in which the event happened or occurred. Okay, suppose on the random experiment I take a toss of a coin. I have taken toss of a coin, and the event I take head. It should be head. Okay, then suppose what happened when I perform the experiment. First, suppose I have made 100 trials. Okay, then probability, if I take 100 trials, and suppose out of this 100 trial, it may be only 23 head occurred, or it can be like this: 75 head occurred. Okay, it can be like this. Now as we increase the number of trials, then we have increased the number, say we made it 1000. Then it was found that it will be say 410. Okay. Then further we increase the number of trials, say 10,000. Okay. And say suppose it is something like that. Now you see what should be the probability ideally. That means when I toss a coin, and if the coin is unbiased, means there is no flaw in the coin, that is the chance of occurring the head or tail are equally likely, then ideally, it should be 50-50, we say. The chances 50-50, we say. That is 50% chance is of occurring head, and also 50% chance of occurring a tail. So ideally the probability should be in this case it should be 0.5, half or 50% is 0.5. It's ideally. But if you observe, when I do the experiments, then you see when the number of trials is less, it is far away from 0.5, because in this case it is 0.23 or 0.75. Okay. And in this case it is 0.41, and in this case it is 0.5012. So as we see, as we increase the number of trials, the probability value is approaching the ideal value. So this definition, that is, if we have to perform a large number of trials, then only we will be getting the correct value of the probability. So sometimes this was not possible to make a large number of trials. There was expensive, it will be expensive in some cases. In some cases it cannot be, it may not be feasible also. So these were the limitations for following this definition. So in 9th class you have come across this definition. So, and this definition known as the empirical definition. Empirical probability. Or that means experimental probability. That means you have to perform experiments to know the value of the probability. So in 9th class this was the definition, and I have shown you there are some limitations for following this definition. So there was a need for a theoretical approach where we can avoid performing large number of trials. So in 10th class we'll come to this, that is now in 10th class we will not go for this definition, that is from from experimental or for empirical we'll switch to theoretical definition probability. Okay, so the theoretical definition is possible, theoretical or classical probability is possible only we make some assumption. And what is the assumption? Assumption that the outcomes of the random experiment are equally likely. That is very important assumption. Only then, when the outcomes of the random is equally likely, then only we can give a definition, theoretical definition of probability. And what is the definition? The definition this is that theoretical probability probability is given by, now we will not be performing trials, so what we do, we find the number of, let me write in proper way, number of times in which of a favorable cases, let me write down in this way, number of outcomes favorable, number of, let me write down properly, number of outcomes favorable to the event E upon total number of possible outcomes. Okay, number of all possible outcomes. So the number of all possible outcomes of the random experiment, or let me write it only simply the experiment, okay. Number of all possible outcomes of the experiments. Here experiments mean the random experiments. Okay. Assuming, this is very important to write this assumption, assuming all the outcomes of the experiment are equally likely. That is the most important thing. So this is the assumption. Under this assumption only, that is all the outcomes of the experiment are equally likely, then only we can follow this definition. Then this definition is known as the theoretical definition, theoretical probability or classical probability. And this definition was given by the mathematician Laplace, Pierre-Simon Laplace in 17th century, 1795 I think. So it is given by yes, 1795, right. So sometimes this definition is also known as Laplace's probability. So now, from now on, we will not go for this empirical definition. We will follow this theoretical definition if this condition is satisfied that the outcomes of the experiments are equally likely. So okay, so this is the basic definition, difference between empirical probability definition and theoretical probability definition. These experiments were done here. Under some assumption we find out this. Okay. Okay, so I told about the limitations of this definition and why there is a need for this classical definition. I think this is clear to you. Now you see, now again if I take that random experiment tossing a coin and the event to be head, so what will happen according to the classical definition? So when I toss a coin, number of outcomes favorable to E, that is only one, only head. So that in that case I can write this number of outcomes favorable to is one, only one head is there upon number of all possible outcomes of the experiment, that is head and tail, on two possible outcomes, then I write 2. So and that is nothing but 0.5. Exactly the ideal value I got by this classical definition. Okay, so these are the definition. Now I give some more basic terms. Let me erase this, empirical one is not required. Now one more thing, should I tell about this? I told you about the value also, it lies between 1 and 0 and 1 that I told you. And okay. Now next let me give you about how many kinds of events are there. Events are of two types. One is elementary event and another is your compound event. Let me erase this also. Compound event. So elementary events, when there is only one outcome, the example I can take just now that I told you, that is toss of a coin and when the event is to be head, only one outcome. And compound, when there is more than one outcome, For example, when I throw a die and if I define the event to be, say, even number, then the event, the E will have so 2, 4, 6. So there are 3 elements in the event. So it is a compound event. But where in this case is only head. So it is an elementary event. So this is the basic difference between elementary event and compound event. Okay. And then what should I tell about this? Okay, complementary event also I should tell you. So, okay. So let me erase this one. Complementary event is denoted by E bar, which means not E. So in this, suppose in this case, if I define E to be head, then what will be E bar? E bar will be not head. That means E bar will be, it has to be tail. If the random experiment is toss of a coin. And you see, probability of head we have seen by the classical definition, theoretical definition 1 by 2 that you've seen. Similarly, probability that it will be tail is also have one tail and 2 possible outcomes. So this. So sum of these two, that is probability of head plus probability of tail, is half plus half, that is 1. So I can say probability of an event plus probability of its complementary event is 1. That is very important result. This one. Okay, P of E plus P of E bar is 1. Similarly, okay, so this is for toss of a coin. Now if I consider the random experiment to be throwing a die, then again what will be the elementary events? The elementary events will be for throwing, when I throw a die, it can be 1, 2, 3, 4, etc. If I consider any number, then the probability that it will be 1 will be this, plus probability the number will be 3, the probability that will be 4. There are 6 possible outcomes. 6 possible outcomes. So by the definition of theoretical definition, the probability of this will be 1 by 6. Again, this is only 1, 2 is there, so 1 by 6. Only 1, 3 is there, so it is also 1 by 6. Similarly, only 1, 4, and it is also only 1, 5, only 1, 6. So by the definition, the denominator was the total number of possible outcomes. There are 6 possible outcomes, 1, 2, 3, 4, 5, 6. So these were the probabilities, and of these all are elementary events then. All are elementary events. Then the sum was 6 by 6, so it is 1. So that we also come to another definition, that is the sum of probability of all the elementary events of a random experiment is 1. That is also, we can write down sum of probabilities of all elementary events of a random experiment is 1. These results are very important. This one, that is sum of an probability of an event that is complementary, is 1, and these two. These are to be useful in solving some questions. Okay. So this is all about the theory part of the probability that will require in 10th class. Now I'll be showing you the applications of this theory by solving some questions. Okay. So the question that I've taken, a die is thrown once, find the probability of getting a prime number, a number lying between 2 and 6, and an odd number. So let me first write down the definition. The probability of E is the number of outcomes favorable to the event upon number of all possible outcomes of the experiment. All possible outcomes of the experiment. This was the theoretical definition. We will follow this. Now let me first define for the first part, what is our event? Event is a prime number. So the prime numbers, now before that let me write total number of all possible outcomes, that we denote by S. That is, so what will be S? 1, 2, 3, 4, 5 and 6. So these 6 numbers are there in a die. And what will be E then? Number of E is your prime number. So prime numbers out of this and these are the prime numbers. So 2, 3 and 5 are the prime numbers. So we define. So that is the set of all possible outcomes. These are sometimes known as sample space. So I have given S. So this is your all possible outcomes. So by the definition, first probability of the event in the first part will be 1, 2, 3 is the favorable outcomes, and number of all possible outcome is 6. So it is half. Okay. Then the second part. In the second part, what is the event? The event, which numbers the E will have? Number lying between 2 and 6. That means this part. Between 2 and 6, 3, 4, 5. So 3, 4, 5. So what will be the probability? Number of outcomes favorable to E is 1, 2, 3, and number of all possible outcome 1, 2, 3, 4, 5, 6. So this is also half. Then the third part, an odd number. So obviously, what is E in the third part? Odd numbers are 1, 3 and 5. These are the odd numbers. So again the probability, number of favorable outcomes 1, 2, 3, that is 3, and total number of possible outcomes 6. So this is, so the probability is same for all the three cases. Next question, a bag contains 3 red balls. So a bag contains 3 red balls plus 5 black balls. Okay, this is the bag, and one ball is drawn at random. You have to find the probability that the ball drawn is red. So the probability, the first part, that the ball drawn is red will be again by this definition, number of outcomes favorable to E. So how many 3 red balls are there? So 3 is the number of favorable outcomes upon total number of all possible outcomes. So 3 plus 5, that is, this is the total. So 3 by 8 is the probability, the first part, that the ball drawn is red. Then the second part, as you see, red not red, that means it is the complementary event. Or if I write in this way, P of E was your 3 by 8. So your probability that it is not red is nothing but P of the complementary event. That is, it will be complementary event, and by the definition it is 1 minus P of E. So 1 minus 3 by 8, I can directly use this, 5 by 8 is the answer. And you write, since I have shown you before, that is sum of the probability of an event and its complementary event is 1. Because of this, I can, if I know the probability of an event, P of E, I can find out the probability of complementary event by this relation. So, and in both the cases, the outcomes are equally likely. You see, if the die is unbiased, is a perfect, flawless, then when I throw a die, the chance of or likelihood of occurrence of any one of the number is same, equal. Similarly, here also, all balls are of identical size. So without looking, if I draw a ball or pick up a ball, then the chance of getting red or blue, black will be same, equally. So in both the cases, the outcomes are equally likely. Okay, so in a random experiment was throw of a die, outcomes are equally likely. So I use the theoretical definition. Here also the random experiment is drawing a ball from a bag where the balls are uniformly mixed. So the outcome is also equally likely. So I can use this definition, and in this way I have solved. So in next video I'll be solving some more complex problem. So that's all for today. Bye.